have your Endeavor cards all the way up to date, but I just want to show you guys a couple things. For tomorrow's Endeavor quiz, you just need to know starting at Taylor polynomials, right? And Taylor Maclaurin's, like, are they really that much different?
Yeah.
One's at C and the other one's at when C is 0. So, I mean, it's not really all that different. You have your special Maclaurin series that you definitely need to know, but you need to have those down anyway. Your Lagrange error-bound formula. Taylor Maclaurin series, what's the difference between these and the polynomials? Series, and they're infinite, so therefore I can put equals and dot, dot, dots, right? So the only difference is equals and dot, dot, dots, versus for an nth degree Taylor polynomial, it would only be approximate for the function. But otherwise, the formulas are pretty much the same. And so we only need to go down to, here we go, convergence using, in a sense, kind of the idea of the ratio test, testing the endpoints. And then I just put in a quick little hint. Bless you. Last year, test the endpoints, you need to know your convergence and divergence test. Now, you don't need to know the convergence and divergence test for the Endeavor quiz. But on the test, if you have to test at endpoints, do you have to have a recall, an understanding, and ability to use things like the nth term test, the limit comparison, probably not limit comparison. Maybe the ratio test, maybe the limit comparison test, maybe, what's another easy one that you would use? Maybe the integral test. But you have to at least be able to, if you're testing the endpoints, remember, we're just going back to our old school convergence, divergence test. So for Wednesday, I would say you should probably review those for sure. But for tomorrow, you'll need to know the Taylor, the Maclaurins, the special Maclaurins, and then Lagrange and interval of convergence. Huh? Yeah. Yeah. And I wanted to show you guys the very next one. Like, you'll know when to stop studying because length of parametric path, yeah, we haven't done vectors or... It's not too bad. Chapters 9 and 10, well, 9 and then 9 OT. Well, no, didn't we have 9A, then 9B, then 9 OT? Anyway, chapters 9 and 10 are the hardest and the widest, deepest as far as the BC topics. So we'll be on like a downhill slope in chapter 11. All right, you guys good with the endeavors, what to study for tomorrow? Yes. Go team. All right, here we go. 10-4, 10-5. Now that everybody is back and everybody is here, color pens, let's go ahead and grade. And you guys can ask questions along the way. I think I have the book up and running. I was trying to. I almost do. For any questions that you guys have, let me get the ebook loading. It'll probably give me an error like 5 times, and then maybe it'll work if that's the normal. Let's see. P.S. Today, starting around 4-ish, I am going to kind of transition my after-school room to pretty much Nicaragua-only kids between 4 and 5-ish, and then we have a mission meeting. Just for those of you guys that stay late, I want to give you a heads up. Oh, I should have texted today. Do you want a group chat and be like, hey, reminder guys tonight? I think Sam Lou might be sick today. And then Jack has a baseball game. But Kindle's coming, so we'll probably just record like her talking about Nicaragua and then we can send it to them. I know, why aren't you going? It's so sad. It's okay. John, be praying for us and supporting us from afar. All right, 10-4, 10-5. Here we go. Number 14. Final answer is 0 is always less than 1, so therefore it converges. You could say negative infinity to infinity, or you just could say for all values of x, and the radius of convergence is infinity.
I was confused. So when you have the x squared over n plus 1, what are you supposed to do with the n? Why?
Oh, remember, the n is what's approaching infinity. The x is, it's not a constant, but
So that's what
you're only having, right.
So is that always the thing where if there's an n, it's all the values are going to be infinity?
Yeah, because ultimately, I mean, the x isn't even involved in this limit, so another way of writing it could be x squared times the limit as n goes to infinity of 1 over n plus 1.
Okay.
So in a sense, like the x is completely separate from the limit.
Okay, that would help.
Does that make sense?
Yes.
Okay, then that goes to 0.
26.
Number 26. You end up with the interval of convergence between 1 over e and e. Wait. Where's their testing the endpoints? Why didn't they test the endpoints?
Geometric series.
If you saw it was a geometric series, you know that the common ratio has to be less than 1 greater than -1, not including. So geometric series, there's no need to test because it will always fail. You guys are wondering how the 1 over e? Your common ratio was ln of x. And remember, common ratios between 1 and -1? And so they raised e to the -1, 1 over e. Does that make sense? And then did they say something like write it as a common function or something to that effect? Oh, they just said find the sum? Okay. So then just finding the sum, you guys just plugged in a sub 1 over 1 minus r, and then you were done. They could have said something like write it in terms of a function, and then that would have been the same answer. But okay. Number 58, final answer was C. I think. The limit ended up being just 2x minus 3 in between 1 and -1, or less than 1, I should say. They went ahead and did some weird factoring, whatever, but same idea as adding 3, dividing by 2. They show it with the yucky absolute value. That works, I just don't like it. Did anybody actually solve for x, or did you not need to?
I did. I thought I did get 1 to 2.
1 to 2? Oh, you were just looking for the radius of convergence. Okay, cool. I was about to get on you guys for testing the endpoints, but if you weren't looking for the interval of convergence, it makes sense why they shortcutted their work too. Okay, thank you, thank you. 60 was D, as in delta. Whoa, whoa, what'd they do?
They split it.
Partial fractions.
They kept doing the sum.
They kept doing the sum until you could get the nth term of the partial sum, and they took the limit as I went to infinity. Was that a nice one?
No.
No. Pause. What's a nice name for this type of series? Oh, they gave you the hint? So partial fractions, then aren't you just going to see that everything's going to cancel out?
Yeah, pretty much.
So you end up with 1/2? That wasn't that hard. Yeah, on the partial fraction part?
Yeah.
Okay.
Did you go over the cover-up?
Yeah. Okay. It makes sense that we want to, well, did they give it to you guys factored or no?
It's right there.
Okay, I know what's in the answer key.
No, that's the way.
Oh, that's how they gave it to you. Perfect. Okay. I mean, they were nice to you. Some of you, admittedly, would probably mess up the factoring. But anyway, here we go. 3n minus 1. Hopefully not. Hopefully not. Okay. Cover-up method. Cover? Who?
That's 1/3.
1/3.
Multiply to the top.
Where do you put it in? The only place where there's an n. Now, if there were n's all over, plug it in everywhere, but there's only an n here. So 1/3 times 3 is 1. 1 plus 2 is 3. 3 over 3 is 1. I covered up him. So then you guys tell me what to do.
You cover up the second one.
Is the 0 that you plug into the other.
The other, but then once you solve for that other,
You
put
put
over
it.
the one you did.
Yeah, the one you covered.
You cover up that
So therefore, I need to cover this guy. I plug in. I plug in over here. So that'd be -1, right? Oh, -2/3, the 3's cancel. -2 minus 1, -3. Okay, so the -1 goes where? Does that make sense?
Yeah. If it can't,
Be the cover-up method?
what if it's not 1? Is that
Oh, we've had ones before that were like 1/5 and 4/5 or 2/3 and
that's alright?
or 5 and 7. Yeah. Yeah. Because remember back in partial fractions, maybe you don't, but there was like big A's and big B's and big C's, and we just solved, and they were random numbers.
Dx plus z.
Yeah. When it was a weird quadratic that was irreducible.
Does the cover method work when you have when one of the fractions is on the bottom of x squared?
No. Struggle is this. If this was it, this would be illegal and impossible to do the cover-up method for 2 reasons. Number 1, that's a quadratic that you can't factor down anymore. His zeros would be imaginary. And number 2, this is a repeated linear factor. If you have either this like squared, cubed, whatever. If you have a repeated linear factor or an irreducible quadratic, you cannot do the cover-up method. What would you do? Katrina just said this one, the ax plus b, and then c over n minus 2, and then d over n minus 2 squared. You would get rid of all the denominators by multiplying the denominators to both sides. Then you would end up, I guess that should probably be an n. Lo siento. Okay. You would multiply the denominator to both sides. When you do, everything would simplify down to like this big old nasty expression with 1, 2, 3, 4 unknowns. You could do probably the easiest way, the least mathematical, but the easiest way would be like, hey, but this whole n equals 2, I thought that was a trick, and it is. Plug in n equals 2, it'll simplify out half of it. Plug in n equals 0, plug in n equals 1, plug in n equals -1. And in those systems of equations you can solve. That's one way, using the cover-up idea. The other way would be to multiply a denominator to the other side, FOIL everything out, and then say, okay, this side says 0n cubed, 0n to the 4th plus 0n cubed plus 0n squared plus 0n plus 3. That's what this guy is. You would get all your n to the 4ths set equal to 0. Get all your n cubes set equal to 0. Get all your n squared set equal to 0. Get all your n's equal to 0. All your non-n's equal to 3. And you would be able to solve that system. It would just be nasty. Go team. Partial fractions pre-cal review in 2 minutes. Okay. Pre-cal did have hard ones. That's true. Number... Oh, thank you. I was like, what? Okay. 10.5. Okay. Using the ratio test in a sense and then going through your testing for the interval of convergence, right? Should have been closed on 1/3, open at 1. Closed at 1/3, open at 1. So testing at 1/3 should have worked. Testing at 1 failed. Letter B for absolute convergence. 1/3 is not absolute. It's only conditional. So you would have left out both of them because of letter C, it being conditional at 1/3, meaning it must be an alternating series. Bingo. And the absolute value 1 over n diverges P series. P equals 1. Kyle. Yeah. Right. And you plug into the X spot at the very beginning. And you test the convergence divergence of the series with that endpoint plugged in. Close it, and if it diverges, then open it. Because you're testing for the convergence. So if it converges, check. If it diverges, leave it out.
And then do you also need to check it then? Does that make sense? You know how you like check the endpoints? Was that not his question?
That was the entirety of the question. So yeah. So he hadn't done. He was asking about the checking the endpoints part.
Okay,
Does that make sense?
If it diverges, you need to check it.
No. If you plug in the endpoint, say endpoint A, right, A to B. If you plug in A and you test the convergence divergence using parting, using all of our different ones, picking one, and if this converges with the endpoint A plugged in, then close it at A. If it diverges with B plugged in, then keep it open at B like this one was. And there's not really any further thing to do.
That is checking the endpoints?
Got it.
Because wasn't in the other one when you check the endpoints, if like it did, that you just like erased it?
Hold on. I'm trying to think what you mean.
I thought in the video you plugged in like that one and you're like, well, that doesn't work, and then you like erased it.
Oh, I crossed it out, but then in my answer it was an open interval.
Oh, okay.
So crossed out means don't include it, don't or equal it, don't close it. Does that make sense? Yeah. But don't leave it because it's still the boundary. It just needs to be open. Number 44. Can I go straight down? Interval of convergence closed, -4 to 4. Absolutely would be open because it's conditional at -4. But guys, if the AP asks interval of convergence, they're not asking conditional versus absolute, unless the question literally says absolute versus conditional. But otherwise, interval of convergence, it would just be closed -4, open at 4. 68, B. 68b?
That's it.
I think that's it. Okay, questions? Evens, odds? I'm here. Corey.
68 and 60. Or can you just
Okay.
68 up there?
Yeah, since we're up here. This was the original problem, yeah? And we're trying to do interval of convergence? No, absolute? Oh, they didn't even show that part, did they? Huh. Okay. Okay, so then our interval of convergence, we're using a sub n plus 1 over a sub n. When I look at it, I can see real quick that you can cancel out the, well, cancel out the n with the n. And then I see an n squared on top and an n squared on bottom. So degrees are tied. The coefficient is just 1. So I can just do 1, 2x minus 5, less than 1 is what I'm doing there. Now they're doing this whole thing where they're dividing by yada, yada, yada. I would just say, I mean, make life easy on yourself. I would just put it in between 1 and negative 1. They're not asking for the interval of convergence, so I'm not going to test the endpoints because that has no bearing on the radius. I just care about the distance in between. Does that make sense? I'm not skipping a step. I'm just looking at the context of the problem. The radius does not need me to know the endpoints because at the endpoints are dimensionless width. I mean, there is 0 width at the endpoint, so it doesn't add or subtract from the radius. Corey, sorry, any question up to here? Okay, so then I would go ahead and add the 5 to both sides, so you'd end up with 4 and 6 with a 2x in between. Then you would end up with x's in between 2 and 3. And then you just take the, now I don't even care the or equal to, that was my whole testing the endpoint thing. I just care the distance is 1. So what's my radius? 1/2. Because 3 minus 2. You literally just take,
you do subtract it.
yeah, you just figure out the width of the interval, and the radius says cut in half.
It's like 1/2 a minus b.
Yeah, b minus a. Yeah. Which, I mean, it should always be positive. But don't ever make it negative. But yeah. Is that okay? Cool.
Oh, yes.
And then 69 was similar, yeah? Okay. Any other questions besides the 68, 69? We're okay? It's okay if you're not. Huh? You just, Kyle. 14 on 10-4, 10-5. Oops, back. Did it end up working? It did end up working. Sorry, 10-4, 10-5, I forgot. 10-4. I'm going to go here. Yeah. Radius of convergence. So once again, guys, with the radius, do we really care about the endpoints?
No.
It's just going to take more time, right?
So, right now, when you said the limit equal to 0, right? Yeah. So there's no.
Because it'd be x to the 2n plus 3. Yeah. Hey guys, do you remember how to simplify this? I mean, you did it in homework, but what does this end up becoming? Good. Because when you subtract 3 minus 1, you end up with x squared. And then the n factorial cancels with that guy, so you get n plus 1. So yes, the limit is 0. True.
Always less than.
Right. So when you're doing the statement, the whole point is a sub n plus 1 over a sub n is less than 1 when? Well, 0 is less than 1. True. Therefore, the interval of convergence would be, and then the radius basically says from the middle, moving one direction. Like, what's the magnitude of this? And, well, the magnitude of this is infinity.
Why do you say that is from negative?
Oh, 0 is always less than 1. There is no condition as to, I don't care what x is. No x will ever make the limit as this guy goes to infinity ever be anything but 0.
So if you don't see a clear ratio, you. No, the statement 0 is always less than 1 means that for all numbers, it's always less than 1. So
It's not conditional on the x at all. Because remember, we could pull this x out. This is 0. So any x value times 0 will always be true. So whether x is, well, it doesn't matter. Whatever value of x, since this limit is going to 0, then I can just say always true. So interval of convergence is negative 52
So,
infinity.
like, since before we would have, like, at the end, we would have, like, a ratio less than
X was remaining,
so x was remaining.
so we had to solve for x. Yeah, yeah. But if x disappears, I mean, false, then never, right? True, then always. Yeah. Okay. I think we got through our questions, yeah? All right. Kiddos, before I totally just let you guys get back to working on your review, which, I know life is crazy. I know that this section is hard, and I didn't want our Endeavor quiz today. Since our Endeavor quiz is tomorrow, we do kind of get a work period tomorrow, but the more that you try of your review, the more you can ask questions tomorrow that you're stuck on, right? Do you guys have answers in the back for it? Yep. Okay. Really quickly, we never took this page of notes, and I'm not exactly sure if it's super important, but these are legal techniques with manipulating special series. We've seen things like, for instance, if I was to ask you to write the first 4 terms in the general term of sine of 2x, what would you do? Okay. Whoa, whoa, whoa. Guys, you're scaring me now. If I was to ask you to do a Taylor polynomial expansion, like the 3rd degree Taylor polynomial of this. Okay, you would memorize, hopefully, your Endeavor card. Sine is odd, so you have x minus x cubed over plus. Okay. Okay. It's okay, don't judge. Shh, they're still memorizing. That's why the Endeavor quiz is tomorrow, not today. Okay, so we can just in true. Okay, what's number 2? Multiply or divide by a constant or variable.
Oh, what's the constant outside? You can substitute sign for the polynomial.
So what if you had something like, for instance, ready? 1 minus, you probably know what I'm doing, x squared over 3 factorial plus x to the 4th over 5 factorial. Who is that?
Oh, sine over x divided by x.
Sine of 1 over x?
Because didn't you guys just tell me that sine of x was x minus x cubed over 3 factorial, x to the 5th over 5 factorial? This is sine of x, but what's been taken away every time? So you can do something like, oh, and didn't we have one where it was like e to the x plus 1 or something like that? Minus 1, because the 1 was missing, but everything else was there. I guess that'd be add or oh, no, never mind. That's different. But yeah, you can, anyway, you can multiply or divide or add or subtract with one of your special Maclaurens. What's number 3 talking about? What if you were to do something like, okay, hold on, this is going to take me a second. Hold on. Keep me honest, Jason. He has it more memorized than the majority of you. Careful. It's cosine plus sine, or sine plus cosine. So you could add, cosine is this one, and sine is this one. Because think, cosine starts x to the 0, even powers. Cosine starts x to the 0, sine starts x to the 1. Cosine's the even powers, sine's the odd powers, because cosine's even, sine's odd. We've already done a lot of work with differentiate or integrate, right? So we know that we can, for instance, go from 1 over 1 minus x, integrating him to be negative ln of 1 minus x, right? Things like that. And then recognizing the series as the sum of a geometric series, if we had something like 1 plus, well, let's make it easy, e to the 2x plus e to the, oh no, that works. 1 plus e to the 2x plus e to the 4x plus e to the 6x. And they said write that, write the sum or find the series or rewrite the series in terms of a common function. What would you do? Oh, you guys are making it too hard. It's geometric, yeah. So that's what number 5 is about. It's like, wait. If it's geometric, then just throw it in the sum formula and be done. There is no extra stressing about it. Now, I kind of gave you one that obviously wasn't one of the Taylor-Maclaurens, so I was kind of trying to help you a little bit. But yeah, you're right. E to the 2n would be the nth term, but that doesn't really help unless you realize it's geometric. Let's just pop it in. Does that make sense, kind of? Okay. If you want to take a picture of the slide just kind of gives you ideas. If they say something like rewrite in terms of a common function, or they want you manipulating forming Taylor or Maclaurens, and they're not super obvious, not super easy, they could ask you any of these things or give you problems that make you realize or practice any of those things. But otherwise, guys, well, you know, we have 2 minutes. You guys had a little bit of time at the beginning. Sorry. Play with it tonight. Come tomorrow with questions. Pretty much work day. Sound good? Okay. Except for endeavors. Study endeavors tonight for quiz tomorrow. Yeah. Yeah. Guys, there's no book test review. There's no book test review. It's just the packet. Unless you want to look in the book, but you don't have to.